So for question number 7, it says that a model rocket with an initial mass of 4 kilograms is launched horizontally. Oh, horizontally. So it's launched this way. Okay. So then, what is the velocity of the rocket after the fuel is expelled? Now, there's a couple ways you could do energy and stuff like that. But remember, in the x direction, nothing is acting on the rocket. We're going to assume the rocket's high enough that free fall doesn't prohibit. In other words, it isn't going to hit the ground. We're going to assume that this rocket is shot high enough that it's still in the air and it doesn't hit the ground. So there's really no external force acting on it. So the rocket, this is an interesting one. The momentum is conserved. So we're going to do this two ways. We're going to do the momentum of the rocket should be equal to the momentum of the fuel. And then the fuel goes on its own path. It actually disappears, but that's okay. So let's write that out and then do some math, and we'll see how that works. So we're going to do the momentum of the rocket should be equal to the momentum of the fuel, right? And remember that momentum is the mass times the velocity of the object. And eventually what happens is the fuel goes away, and then we are left with the momentum of the rocket. Well, what is the mass of the fuel? Well, they tell us it's 800 grams, but we have to convert that to 800.8 kilograms. And then the rocket's initial mass is 4 kilograms. So the rocket is technically 4 minus the 0.8, which is 3.2. So remember that momentum is, so the momentum of the rocket is the mass of the rocket times the velocity of the rocket, and that should be equal to the mass of the fuel times the velocity of the fuel. Okay? So then what I'm going to end up with is the mass of the rocket is 3.2. I don't know what the velocity of the rocket is, but that's what I'm solving for because we want the velocity of the rocket. But I do know the mass of the fuel, which is 0.8. 0.8, and then that's got to be multiplied by the velocity of the fuel. And we know that the fuel has a velocity because they tell us the velocity of the fuel. And let me explain what they mean by the fuel and all that stuff. With rockets, there's equal and opposite reactions. So the rocket goes this way because the fuel goes this way. Okay? And so what do I do? Well, I'm going to take both sides and divide by 3.2, even though I wrote down 3.3. So I get that the velocity of the rocket is going to be equal to this 0.8 divided by 3.2 multiplied by 100. If you do that on a calculator, it's actually 25 meters per second. So this would be 0.8 kilograms divided by 3.2 kilograms. So those cancel, and I'm left with meters per second. So that's the answer. That's conservation of momentum. Well, I don't want to oversimplify this. There's an opposite and equal reaction, but remember there's kind of fuel in the rocket too. So we'll deal with that later. Any questions? Okay, that's it.